In this video, you will learn how to efficiently convert TensorFlow models to ONNX format, optimizing your AI workflow across platforms. Let's dive into the steps and skills needed for seamless conversion. Welcome to our tutorial on converting TensorFlow models to ONNX. Did you know that ONNX is becoming the go-to format for AI models due to its interoperability? By converting your models, you can seamlessly integrate them across different AI platforms, enhancing workflow efficiency. In this video, we'll walk you through everything from setting up your environment to optimizing your converted model. Let's get started. ONNX, or Open Neural Network Exchange, has revolutionized how AI models are shared and implemented across different frameworks. But why is ONNX important? Essentially, it acts as a bridge, allowing models created in one ecosystem to be used in another without compatibility issues. This is crucial for developers who want to leverage the strengths of multiple AI platforms. With ONNX, you can streamline your workflow, making it easier to deploy models at scale. As more companies adopt ONNX, the future of AI looks more interconnected than ever. Before diving into conversion, it's crucial to have your TensorFlow environment properly set up. Start by installing TensorFlow and its necessary dependencies using pip install TensorFlow. It's best practice to use a virtual environment to manage your Python packages, ensuring compatibility. If you haven't set up a virtual environment before, don't worry, it's as simple as running Vend in your terminal. Once set up, test your installation by running a basic TensorFlow script. This step ensures your environment is ready for model conversion, setting a solid foundation for your workflow.
With TensorFlow ready, let's move to installing the ONNX conversion tools. The primary package used is TF2 ONNX, which you can install via pip install TF2 ONNX. Ensure your TensorFlow version is compatible with the TF2 ONNX version by checking the official documentation. After installation, verify it by converting a small sample model. Having these tools set up allows you to easily translate your TensorFlow models into ONNX format, ensuring they can be utilized across different platforms without hitches.
Now, let's go through the conversion process step by step. First, export your TensorFlow model to a saved model format. Next, use the TF2 ONNX.convert command to convert the saved model to an ONNX model. During conversion, check the model layers to ensure complex operations translate correctly. If you face any issues, TF2 ONNX provides comprehensive logs to help troubleshoot. Finally, save your ONNX model and verify its integrity by loading it in an ONNX-compatible framework. This process ensures your model retains accuracy and performance post-conversion. Conversion errors can be a headache, but understanding common issues makes them easier to handle. Common error messages often relate to unsupported operations or mismatched input shapes. To debug, start by reviewing the error logs provided by TF2 ONNX. Adjust your TensorFlow model if necessary, focusing on simplifying complex operations. Another useful tool is the ONNX Model Checker, which helps ensure your model adheres to format standards. Don't forget community resources. Forums like Stack Overflow or GitHub issues are invaluable for finding solutions to similar problems others have faced. Testing is crucial to ensure your converted ONNX model performs as expected. Start by loading your ONNX model into an ONNX runtime environment. Perform inference tests using the same inputs as your original TensorFlow model to compare outputs and verify accuracy. Benchmark the performance to ensure the conversion hasn't introduced latency or reduced efficiency. By carefully comparing results, you can confirm that the model's functionality is preserved, maintaining both accuracy and performance post-conversion.
One of the great benefits of ONNX is the ability to easily integrate with various AI platforms. Deploy your ONNX model on platforms like PyTorch or Caffe2 using the ONNX runtime. This compatibility allows you to leverage the strengths of different environments, whether it's for research or production. Implement cross-platform deployment strategies to maximize the utility of your model, ensuring it can be used in diverse applications. This flexibility enhances the robustness of your AI solutions, making them more adaptable to changing technological landscapes. Optimizing your ONNX models ensures they run efficiently and effectively. Start by optimizing the model graph to remove redundant operations. Use ONNX optimizers, which are tools designed to enhance model performance by simplifying computations. Leveraging hardware acceleration, such as GPUs or specialized AI chips, can significantly boost performance. Regularly profile your model's performance to identify bottlenecks and areas for improvement. Implementing continuous improvement strategies ensures your models remain competitive and efficient, adapting to evolving computational demands.
Congratulations on mastering the conversion of TensorFlow models to ONNX. We've covered the entire process, from setting up your environment to optimizing your converted models. The benefits of using the ONNX format are immense, providing flexibility and interoperability across platforms. I encourage you to practice and experiment with your own models. Engage with the AI community to stay updated on the latest trends and solutions. If you found this video helpful, please like, share, and leave a comment with your thoughts or questions. We love hearing from you and learning about the topics you want us to cover next.